addition of HCl. Okay, addition of sodium bisulfite, addition of water. Addition of water is known as hydration reaction. Okay. Then addition of alcohols. Then reduction reaction. Reduction reaction. Okay. Reduction reaction. Number 1, lithium aluminum hydride, sodium borohydride. Okay, sodium borohydride, lithium aluminum hydride. These are the reducing agent. Can be used to reduce both aldehydes and ketones to their corresponding alcohols. This is the aldehyde, and reduction means addition of hydrogen. These are the reducing agents: sodium aluminum hydride and lithium aluminum hydride and sodium borohydride. It will be reduced to alcohol. Okay. Then Mirwin Pondorf Varley reduction. It is a naming reaction. This method is used to reduce the ketones to alcohols reversibly in presence of aluminum isopropoxide and isopropanol solvent. Okay, these are the solvent used. Aluminum isopropoxide. This is aluminum isopropoxide. This is reversible of opponular oxidation. Always oxidation is the reversible of reduction. Here, this is a reduction reaction, and specially this reduction reaction is just opposite to the opponular oxidation reaction. Here, this is the aldehyde, and this aldehyde will be reduced to corresponding alcohol, okay, in the presence of aluminum isopropoxide. Okay, and this is a naming reaction. Then another reduction reaction. Two important reduction reactions are there. Here, what happens? Wolff-Kishner reduction and Clemmensen reduction. In both the naming reduction reaction, here the carbonyl group is reduced to methylene group. The carbonyl group is reduced to methylene group. In Wolff-Kishner reduction and Clemmensen's reduction, in both the naming reactions, what happens? This is the carbonyl group, and this carbonyl group is reduced to the carbonyl group is reduced to methylene group. This type of reduction occurs in the two naming reaction, that is known as Wolff-Kishner reduction and Clemmensen's reduction. Okay, these are two important reactions. One is Wolff-Kishner reduction and another is Clemmensen reduction. Okay, the reduction reaction is used to convert the carbonyl functionalities into methylene group. This is the carbonyl functionalities. This is the carbonyl group. It will be reduced to methylene group. This is carbonyl group. Carbonyl group. This is your carbonyl group, and it will be reduced to methylene group. Methylene group. Okay. The carbonyl group is reduced to methylene group in both the reaction, in Wolff-Kishner reduction and Clemmensen's reduction. This is your Wolff-Kishner reduction, in which the hydrogen is used as a reagent. Okay, the hydrogen NH2NH2, it is a base. And in Clemmensen reduction, here also the carbonyl group is reduced to methylene group. Okay, in presence of zinc amalgam and hydrochloric acid. Mercury zinc, where the mercury is present, that is known as amalgam. Zinc amalgam and hydrochloric, in presence of hydrochloric acid, the carbonyl group is reduced to methylene group. Okay, and this naming reaction is known as Clemmensen's reduction. Okay, all of you can understand or not? You look forward. Why you are looking below? Okay. Then condensation reaction. Reduction reaction finished. Okay. Then condensation reaction. What is condensation reaction? The aldehydes and ketones undergo another class of reaction which may be called as addition-elimination reaction. First, the addition reaction is taking place, then elimination of water takes place. Elimination of water takes place. Both addition and elimination reaction is known as condensation reaction. Okay? First, the condensation reaction is known as addition-elimination reaction. Okay, first addition reaction will be takes place, then the water molecule will be eliminated out. That's why it is known as elimination reaction. Addition-elimination reaction is commonly or commonly known as condensation reaction. The first example is aldol condensation. Aldol condensation. Okay, two molecules of aldehydes. Here, two molecules of aldehydes or ketones having alpha hydrogen atom. What is alpha hydrogen atom? Do you know? Alpha hydrogen atom. This is CHO. Okay, and CH3. CH3. Here three hydrogen atoms are there, and nearest to the functional group, the carbon bearing the hydrogen atom are known as alpha hydrogen atom. Here three numbers of hydrogen, alpha hydrogen atom are there. Okay. Two molecules of aldehydes or ketones having alpha hydrogen atom combined together. IPO means isopropyl oleate. We have told. Yes, base to form the beta hydroxy aldehyde. Beta hydroxy. At the beta carbon, the OH group will be attached. At the beta carbon, the OH group will be attached. That's why it is known as beta hydroxy aldehyde or beta hydroxy ketone. In case of ketone, at the beta carbon, if OH group is attached, that is known as beta hydroxy ketone. That will further dehydration. Further dehydration of the product that will result the alpha beta unsaturated carbonyl compounds. The double bond is present. The double bond is present between the alpha and beta carbon. That's why it is known as alpha beta unsaturated carbonyl compounds. If the carbonyl compound, if any type of carbonyl compound, C double bond O, okay, it is an aldehyde and it contains the carbonyl compound, and this is the alpha carbon and this is the beta carbon. This is your alpha carbon and this is your beta carbon. Okay, if between the alpha and beta carbon the double bond is there, that is known as alpha beta unsaturated compounds. The beta hydroxy compound, at the beta the OH group is there, that is known as beta hydroxy compounds. The elimination of water results the beta hydroxy compound into alpha beta unsaturated compounds. Okay, do you understand, all of you? Yes. Here, this has been shown. Okay, this is acetaldehyde. Another molecule of acetaldehyde, two molecules of acetaldehyde combine with each other. They have the alpha hydrogen atom. They have the alpha hydrogen atom. In presence of a base, it will form the 3-hydroxybutanol. 3-hydroxy. This is 1, 2, 3, and 3 is known as beta. This is the beta carbon. This is the alpha carbon. Either it has been written as beta hydroxyaldehyde or it has been written as 3-hydroxybutanol. It is an aldehyde, that's why butanol, and at the 3 position the hydroxy group is there. Why it is known as aldol? What is the meaning of aldol? In a molecule, if an aldehyde and an alcohol group is there, if two functional groups are there in a molecule, both the presence of aldehyde and alcohol, indicates that it is an aldol. It is an aldol. Aldol. जेमि कि संधि विच्छेद करा जायनि कोन विद्यालय विद्या युक्त आलय, that is alcohol plus aldehyde, that is known as aldol. Okay, aldehyde and alcohol, that is known as aldol. Okay, and further elimination of water molecule from the beta hydroxy compound, the elimination of OH or water results the alpha beta unsaturated compound. This is the alpha beta unsaturated carbonyl compound. Why? Because between the alpha and beta carbon, the double bond is there. Okay. How the double bond creates? Because of elimination of OH and hydrogen as a water molecule, plus water. This is about your aldol condensation. It is a very important reaction for your examination point of view. Another example has been given. This is acetone. In case of aldehyde, this is, and in case of ketone, this is. For methyl 3 pent-ene on. Okay. Pent-ene means double bond and on means C double bond O. Okay. This is the example of then mechanism of aldol condensation. How aldol condensation occurs? What is the exact mechanism? The reaction involves the formation of carbanion. This is an anion. Carbanion is an anion or cation? Carbonium is cation and carbanion is anion. Here the minus charge is there. The reaction involves formation of carbanion that act as nucleophile. The negative charge species act as a nucleophile and attacks the second aldehyde molecule. The two aldehyde molecules react with each other. First of all, one aldehyde molecule acts as a carbanion, and that carbanion attack the carbonyl carbon. This carbanion attack. This is a nucleophile. This will attack the central carbonium carbon. Okay. Out of two molecules, one will form as a carbanion ion, and that ion will attack the central C+. Okay. This will attack this, and this will form this type of product. Okay. In presence of water, it will form one aldehyde group and one alcohol group. This is beta hydroxy aldehyde. And from the beta hydroxy aldehyde, the elimination of water molecule will form the alpha beta unsaturated compound. And this is the concept of, or this is the mechanism of aldol condensation. Then crossed aldol condensation. In case of cross aldol condensation, what happens? In case of aldol condensation, two reactants are similar. But in case of crossed aldol condensation, two reagents are dissimilar, and they will form different types of products. Okay, and the mechanism is same. Then Claisen-Schmidt condensation. Okay, Claisen-Schmidt condensation. एटी तमरो बुक्स रे अछि आमे बुक्स रे पढ दवा Claisen-Schmidt condensation. This is your Claisen-Schmidt condensation. Okay. This involves the treatment of benzaldehyde with aliphatic aldehydes. Okay. This is Claisen-Schmidt condensation reaction. What happens? This involves the treatment of benzaldehyde. This is your benzaldehyde. Okay. Here there is no alpha hydrogen atom in benzaldehyde. This involves the treatment of benzaldehyde with aliphatic aldehyde. This is acetaldehyde. This is aliphatic aldehyde. This is aromatic aldehyde. Okay. or methyl ketones in the presence of dilute alkali, in the presence of sodium hydroxide at room temperature to form the unsaturated aldehydes or ketones. This is the unsaturated. This is alpha beta unsaturated compounds. To form the unsaturated aldehyde or ketone, this type of aldol condensation is known as Claisen-Skip condensation. It is also a aldol condensation type of reaction, but it is a special type. With aliphatic, one molecule is aliphatic group and one molecule is from aromatic group. This is known as benzaldehyde and this is known as acetaldehyde. This is aromatic types of molecules and this is aliphatic types of molecules. Between the aromatic and aliphatic molecules, the interaction is there. Okay. In the presence of sodium hydroxide, the unstable compound will be formed. This is beta hydroxy. This is beta hydroxy. This is aldehyde. This is alpha carbon and this is beta carbon. And the reaction occurs between the two molecules. The only one have the alpha hydrogen and the aromatic or benzaldehyde have no alpha hydrogen at all. Okay. And this is unstable. This is the beta hydroxy compound. This is beta hydroxy, and by the help of elimination of water molecule, it will form the alpha beta unsaturated compound that is known as cinnamaldehyde. The name of the compound is known as cinnamaldehyde, and this is your Claisen-Skip condensation reaction. Okay. And another, this is acetone, this is benzaldehyde, and the product is 4-phenyl 3-butane 2-on butene 3-butene. This is also alpha beta unsaturated compound. This is alpha carbon, this is beta carbon. It is a type of aldol condensation reaction, but it is a special, the name is special type. This is known as Claisen-Skip condensation because one molecule used is aromatic type and another is aliphatic. In the aliphatic compound, the availability of alpha hydrogen atom is there, but in the aromatic there is no alpha hydrogen atom. Okay. Then minimize. Claisen-Skip condensation without alpha hydrogen atom, aromatic aldehyde. This is your aromatic aldehyde, benzaldehyde. This is aromatic aldehyde. It has without alpha hydrogen atom. This is aliphatic. This is the aliphatic compound, aliphatic aldehyde. It has alpha hydrogen atom. Between the reaction takes place between aromatic and aliphatic aldehyde. Okay. Beta hydroxy compound will be results, and it will produce the benzyl acetophenone or alpha beta unsaturated compound. This is known as Claisen-Skip condensation. Then Claisen reaction. Okay. In case of Claisen reaction, what happens? One is aromatic aldehyde and another plus esters having alpha hydrogen atom. This is an ester. This is aromatic aldehyde, benzaldehyde, and it is an ester. Okay. Esters having alpha hydrogen atom. Here, the methyl group contains alpha hydrogen. This is a ketone. Okay. This is a ester, and it contains the alpha hydrogen atom. It does not contain any alpha hydrogen atom. Okay, and it will form the beta hydroxy compound. It will also form the beta hydroxy compound. Then, by the help of elimination of water, it will form ethyl cinnamate. It is also a alpha beta unsaturated compound. Here the double bond is there between the alpha and beta carbon. Okay, this naming reaction is known as Claisen reaction. Then Parkin reaction. Okay. What happens to the Parkin reaction? Aromatic aldehyde plus acid anhydride having alpha hydrogen atom. aromatic aldehyde, this is benzaldehyde. Okay, this is benzaldehyde, that is known as aromatic aldehyde plus acid anhydride. This is acid anhydride. This is acid anhydride. But in the previous reaction, this is ester. This is your ester. But in case of Parkin reaction, the acid anhydride will react with benzaldehyde. Okay, in the presence of sodium acetate. In the presence of sodium acetate, it will produce the beta hydroxy compound. It will produce the beta hydroxy compound. Then further elimination of water, it will also form the alpha beta unsaturated compound. Alpha beta unsaturated. All the reactions are similar type. Just slight differences are there. Okay. In case of glycine reaction, benzaldehyde plus ester. In case of Parkin reaction, same benzaldehyde plus acetic anhydride. Only the slight differences are there, but all the naming reactions are one category, belongs to one categories, and the products form is also same, alpha beta unsaturated compounds. Okay, this is the mechanism. Here same mechanism is there. Carbanion ion, formation of carbanion ion. That carbanion ion attaches nucleophilic addition reaction. This is the carbanion ion that will attack the carbonyl carbon, and same product will produce. Same product will produce. These are the intermediate reactions. Finally, the alpha beta unsaturated compounds, that is cinnamic acid, will be produced. This is the carbanion. This is the carbanion ion. Negative charge carbanion ion will be produced. That will attack the central carbonyl carbon, and the alpha beta unsaturated compounds. The alpha beta unsaturated compounds will be formed. Okay. Then number 5, that is known as benzoin condensation. Benzoin condensation. Another naming reaction. All the naming reactions are important for your examination point of view. Okay, this is out of 4 unit. This is the important unit. All the naming reactions are coming in your final or semester examination. And all these naming reactions are similar types. It is very easy to remember. Okay. In case of benzoin condensation, what happens? Aromatic aldehyde plus aromatic aldehyde. 2 aromatic aldehydes molecules. This is benzaldehyde. 1 molecule of benzaldehyde. This is another molecule of benzaldehyde. 2 molecules of benzaldehyde react with each other in the presence of CN minus. This is, and it will form the benzoin. It will form the benzoin. Two reactants are simply add with each other. 2 reactants are simply add with C6H5, C6H5, and C double bond O. Okay, CHOH. Benzoin is there. Okay, just like your aldol, it is known as benzoin. Okay, benzaldehyde, and here OH, one alcohol group is there and another ketone group is there. C double bond O is there. And what is the mechanism behind it? This is the mechanism. This CN minus, this acts as nucleophile. This acts as a nucleophile. It will attack the carbonyl carbon. Okay. The carbanion ion will be formed. Here the carbanion. Similar thing, same thing happen. Okay, carbanion ion will be formed. That carbanion ion attack the aromatic aldehyde. That carbanion ion attack the aromatic carbonyl carbon, and finally the OH group and C double bond O, that is known as benzoin. The product form is known as benzoin. Okay. Here only the double bond shifted minus, okay, and that will attack the central carbonyl carbon. Just a bond is there. Okay, the double bond is shifted to this and this minus ion attack to the OH group. Proton shift. The proton shift is there. Okay. This is aromatic C, Cn, and O minus is there. Here OH group is there. Proton shift is there, and in presence of Cn minus, it will form C double bond O, COH. Okay. COH. This is the mechanism of reaction takes place. Benzoin will be formed. The final product is benzoin. The main thing is the formation of carbanion. In the first step, the formation of carbanion, negative charge, and that negative charge acts as a nucleophile, and it will attack the carbonyl carbon. These are the two steps, two important steps. Up to this and this. Okay. These are the two things, important things, and two important things are occurring in all type of reactions. Then what happens? Here proton shift is there. Proton shift is there. This acts as a nucleophile, will attack the central carbonyl carbon. A bond is there, and O minus, the proton shift is there. The H will shifted to this. That's why here O minus will be there, and here OH is there. Okay. Then O minus will form the double bond. Here O minus will form the double bond. That's why C double bond O and CHO is there. And the product, name of the product is known as benzoin. This is the product or benzoin condensation reaction. Then number 6 is known as Reformatsky reaction. Okay. In the Reformatsky reaction, what happens? What are the reactants used? Alpha bromo ester. At the alpha carbon, the bromine is there. That's why it is known as alpha bromo. It is the ester molecule. It is ester. C double bond O C2H5. That is known as alpha bromo ester. At the alpha carbon, the bromine atom is there, plus aldehyde or ketone. It is a ketone, plus R C double bond O R. It is a ketone. In presence of zinc and benzene, it will form the beta hydroxy ester. Here, this is the beta hydroxy ester. At the beta carbon, the hydroxy group is there. Beta hydroxy ester. Okay. Beta hydroxy ester. This is the beta hydroxy ester form, and it is known as, the name of the reaction is known as Reformatsky reaction. Okay. At the beta carbon, this is ester molecule COO C2H5. Here COO C2H5 there. This is alpha carbon. This is beta carbon. At the beta carbon, the hydroxy group is attached. That's why it is known as beta hydroxy ester. And the name of the reaction is known as Reformatsky reaction. Okay. Then condensation with ammonia derivatives. The hydrogen is also a ammonia derivative. RNH2. Okay. This is your ketone. R prime C double bond O. This is ketone. Okay. RNH2. Here double bond is there. C double bond NR. This is known as imine. The amine is converted into imine because C double bond N is there. This compound is known as imine. Okay. Then this is a ketone NH2OH. The oxime is there. R2C double bond NOH. That is known as oxime. The name of the compound is known as oxime. And R2C plus NH2CONH2. That is known as semi-carbazone. The product is semi-carbazone. Okay. Then R2C double bond O. NH2NHC6H5. That is phenyl hydrazone. This is phenyl hydrazone will be formed. Okay. R2C double bond O NH2NH. That is known as 2,4-dinitro 2,4-dinitro, but 2-nitrophenyl hydrazone. 2,4-dinitro phenyl, 2,4-dinitro phenyl hydrazine. The name of the compound is known as 2. This is 1, this is 2, this is 3, this is 4. Okay, that's why 2,4. Nitro group is there. 2,4-dinitrophenyl hydrazine. Phenyl, this is phenyl, this is hydrogen. Plus ketone. The product form will 2,4-dinitrophenyl hydrazone will be produced. Phenyl hydrazine, it will be formed phenyl hydrazone. Okay. Then Manich reaction. What is Manich reaction? All these are naming reaction. Okay. Formaldehyde plus active hydrogen compound plus amine. That may be primary amine or secondary amine. Active hydrogen compound. Then it will form the beta amino carbonyl compound. That is known as Manich base. The beta amino carbonyl compound is known as Manich base. That's why the name of the reaction is known as Manich reaction. Okay. This is acetophenone. This is the reactant. Okay. And HCHO, this is formaldehyde. And NHCH3CH3. This is amine. This is your amine. And elimination of water molecule, that will form the Manich base. This is Manich base. This is beta amino. Okay. Beta amino. This is alpha carbon and this is the beta carbon. Here you notice. This is the functional group. C6H5CO. This is the functional group. Nearest to the functional group, this is the alpha carbon and this is the beta carbon. To the beta carbon, the amine group is attached. This is the secondary amine. Okay, and this is known as beta amino carbonyl compound. This is the carbonyl compound. This is this C double bond O. This compound contains the carbonyl group. That's why it is carbonyl compound, and it is beta amino. The carbonyl compound is attached to the beta carbon. That's why it is known as beta amino carbonyl compounds. C6H5CO, CH2, CH2 and CH3, That is known as Manich base. That's why it is known as Manich reaction. Okay. The secondary amine, here the secondary amine, you notice that secondary amine act as a, it will act as a nucleophile. The secondary amine act as a nucleophile. The lone pair of electron above the nitrogen atom, that will attack the central carbon. Okay, the lone pair of electron which is present above the nitrogen atom, that will act as a nucleophile and will attack the central carbonyl carbon, and this product will be produced. Then hydrogen H plus transfer will occur, and it will form the beta hydroxy or beta hydroxy. What it will form? Beta hydroxy, beta amino carbonyl compound. It will form the beta amino carbonyl compound. Finally, it will form the beta amino. This is your alpha carbon. This is your beta carbon. Okay, beta amino carbonyl compound. Yes. Time. Okay.